So in this, we're going to look at independent and dependent events and calculate probability. However, it's all going to be mixed in. So we're just going to try and look at each situation and determine how to calculate the probability. I want you to recall, just with your brain, that the probability of something happening is the likelihood that something's going to happen, and it's the number of ways to achieve a desired outcome. So like that's what you're calculating the probability of. And it's divided by the total number of possible outcomes. So we have to figure out how many things could happen and how many ways could what we want to happen, how many ways could that happen. So that's what we're going to be looking at. Let's take a look at the first example. There are a couple different ways that we can think about some of these things, so let's just get right into it. We're supposed to calculate the probability, and you flip a coin, and, this is important, and roll a fair six-sided die. The coin lands heads up, and the die shows an even number. So we are trying to find the probability that when we flip a coin, it will land heads up, and the die shows an even number. So these are two separate events that we're combining. And one of the rules for probability, it turns out that when you use the word and, you're going to multiply the probabilities of the two events. If you use the word or, you will add the two events. So what do I mean by event? Well, the first event in this one, the very, very first event, is flipping a coin. And then the second event is rolling the six-sided die. So in the first event, what's the probability that it's going to land heads up? That's all I'm doing right now. I'm calculating the probability of these events separately. So calculate the probability. You flip a coin and it lands heads up. What is that probability? Well, remember, the probability is the number of ways to achieve a desired outcome over the total possible outcomes. So that would be 1, because I can only get heads one way by flipping a heads, and then over 2. It's 50% chance that it'll land on heads. And then for the other event, I'm rolling a six-sided die. So that's one event. How many ways can I land on an even number? Well, that's 2, 4, or 6 out of 1, 2, 3, 4, 5, 6. So that would be 3 out of 6, which is the same thing as 1/2. So each of these events have a 1/2 probability, 1/2 chance. So we can, when it says and, we multiply. So we're going to multiply these two fractions, these two probabilities, and we end up with 1/4, which is not z, it's supposed to be an equal sign, which is 0.25 or 25% chance, 1 out of 4. That'll be the answer, or that, whichever way you want to write it. I would accept both. So that's how we're going to calculate probability. Now I can do it a different way. There's always I can do it a different way. And this is how we discovered that when you use the word and, you multiply. I should write that down. If you want the probability of one event and another event, you can actually do it for more than just two events. You can do it for 3, 4, 5, or any number of events. So if you want the probability of one event and another event, you multiply those probabilities. And that's for simple probability cases. And there's a different rule for or, and we'll see if we get to that. So there's another way. So I'm done with this problem, but I'm going to do it another way, okay? Don't get confused. I'm just going to do it another way. This way is more simple. It's just thinking about the total possible outcomes. So I'm just going to try and list the whole entire sample space. This is like for counting. How many different ways can I flip the coin? Well, I have 2 choices for that, and I have 6 choices for the die. So that would be a total number of 12 outcomes, 12 possible outcomes. So I'm going to list all of those 12 outcomes, and then I'm going to see how many ways I could get a heads and an even number. So one outcome would be I get heads and I get a 1, or heads and 2, or heads and 3. These are all possible outcomes, and I can just list them all. And there we go. But I could also roll or flip a tails and get a 1, or a tails and get a 2, and so on. So those are my 12 outcomes. How many different ways out of those 12, so my probability would be out of 12, how many different ways could I get heads and an even number? Well, how many times does that happen? 1, 2, 3. So that would be 3 over 12, which reduces to 1 over 4, which is the same thing. So this is like, you could list out everything, or you can just think about it. This is kind of the shortcut way, using multiplication. Hopefully that makes sense. We'll do another problem in another video.